Welcome to Rolfes at Boone's Guide to Ohming Out a Cable. Today I am going to walk you through the steps of ohming out a cable. These steps will help you determine if the cable itself is bad or just the lead wire running back to the switch. Your first step will be to gather the tools needed to test the cable. This includes your temperature cable and a multimeter. To begin, you are going to need to find the nearest splice point to the temperature cable. If your cables are hung inside chimney ports, a likely location for this splice would be in the chimney port. If your cables are hung from an eye bolt, a likely location for this splice would be a stub-up or a conduit. These splices should be taped up to keep them out of the elements. You may need a knife to help remove the tape. Before we begin testing your cable, there are a few things you should understand. First, a thermocouple is created by soldering a silver constant tand wire to a copper wire. Our temperature cables have 6 copper wires per 1 silver constant tan wire. Next, each temperature cable has a color pattern. We can use this color pattern to locate where a thermocouple is on each cable. For a Rolfes at Boone temperature cable, we use this color pattern. For example, our white constant tand and black copper wires are soldered together to make our bottom-most thermocouple. Working our way up the cable, we would then solder the blue and white together, then the green and white, and so on. Once we reach the solder for the white and clear wires, we would switch to the next constant tand wire and continue the pattern. Our next thermocouple would use the brown constant tand and black copper wire. If you don't see this color pattern when you look at your splice, then you don't have one of our cables and will need to contact the manufacturer for further steps. Now that you have a basic understanding of how a temperature cable works, let's get started. In our first demonstration, we will be looking at a used cable in decent condition. We can begin by separating our 3 color groups. The orange group. You can tell it is the orange group by looking at the base of the wires. The orange wires are wrapped around the copper wires. This would be your white group. And finally, your brown group. We will begin with our white group since that's the bottom of the cable. Then we can work our way up. We will be pushing one of our probes on our multimeter into the crimp with the 2 white wires. The other probe on our multimeter will go into the crimp with the 2 black wires in the white group. If you look at our multimeter, the resistance is jumping around and cannot find a connection. This indicates that the thermocouple has been damaged. Now we can leave our one probe in the crimp with the 2 white wires and move the other probe into the crimp with the 2 blue wires, working our way up the cable. If you take a look at our multimeter now, you can see a solid number of 64. This indicates a thermocouple that is still intact. Next, we can test the green wire. Now we can see a steady number of 56.2. As you work your way up the cable, these numbers should decrease between about 5 and 10 each time depending on your cable type. Next, the red wires. A steady 48.4 means this thermocouple is good as well. Now let's take a look at a cable that has a few more issues. This cable is only 54 feet long, so it does not use all 18 thermocouples. That is why the orange group is wrapped around the lead wire. Again, we will begin by separating the color groups, white and brown. We can start by pushing one probe into the crimp with the white wires and the other into the crimp with the black wires. As you can see, we got some jumpy numbers again. This would be a bad thermocouple. Next, we can try the white group, blue wire. Here is an example of another bad thermocouple. Since our temperature cable is 54 feet long, our second to the bottom thermocouple should give a much higher reading. If you remember back to the first cable we did, the second thermocouple gave us a number of 64. Since both of these cables are 54 feet long, these numbers should be about the same. Now let's check the green wire. Here is yet another example of a bad thermocouple. The number continues to decrease. If you see this, or the opposite, where a number increases, then the thermocouple is no good. Now let's check the red wire. The steady number 46.9 indicates a good thermocouple. Let's review some key takeaways. A steady number that makes sense for the length of the cable indicates a good thermocouple. Any numbers that jump around indicate a bad thermocouple. Any numbers that increase or decrease uncontrollably indicate a bad thermocouple. If your multimeter won't give you a reading, make sure you are on the resistance mode. This setting is indicated by the omega symbol in the Greek alphabet. If you still aren't getting a number, make sure your probes are touching the metal on the inside of the crimps. If you still don't get a reading, then you have a bad thermocouple. Finally, if your cable is testing good, but your software still gives you bad readings, then you have bad lead wire. If you have any further questions regarding your temperature cables, please reach out to us either by phone or by visiting our website.